Hello, today we're going to look at key concept number 1.
Students, you should now be sitting in your...
So in key concept number 1, we are starting with target 1A. That is, I can apply the properties of integer exponents to rational exponents. Our MLO for this is I can simplify rational exponential expressions by applying the properties of integral exponents to rational exponents. So I'm going to start with some vocab here. First of all, this whole thing right here, the 10x cubed plus 5, is an expression. And then within that expression, we have two terms. I'm going to write this in red. We have 10x cubed and then positive 5. Those are terms. An expression can have as many terms as you would like. And within these terms, we have a couple different vocabs that is going to be very important to know and understand, which you may already know. This 10, which is in front of a variable called the coefficient. And again, that's just a number in front of a variable. In front of a variable. Right, and x is the variable. The 3, or cubed, is the power of the exponent. And then this 5, I'm going to underline it, is a constant. Okay, that just means it's just a number. There's no variable with it. A number, let me calibrate this, with no variable. And then the last thing I want to point out, because we will have to look at this later, and I'll do this in green here, change it up, but this x is the base. Okay, so when something has, a variable has a power, or a number has a power to it, that number or variable is the base. And then the 3 in this example is the power. All right, moving on to the expanded form of these expressions. So for number 1, we have 7 to the 5th times 7 squared. So what I'm going to do is write this out in expanded form. That means we're multiplying 7 together 5 times. That's what the exponent tells us. 7 squared, I multiply that out twice, so 7 times 7. That was nicer. And then if we count all those, since it's all multiplication, it's going to be 7, which is the base. And then we count how many of those there are. There's 7, so that's 7 to the 7th power. Number 2 is the same idea. Negative 4 squared is negative 4 multiplied together twice. Make sure you keep that in parentheses there. And then negative 4 multiplied together 3 times, since 3 is now the exponent. And this is trying to make this look nice for you. Okay, so
Students, this is still your 4th hour class. However, this is about to switch from period 4A to period 4B. Once again, this is still your 4th period class. However, this is about to switch from period 4A to period 4B. Thank you.
All right, so then you see the If you count how many -4s there are 5. So we keep -4 as the base, and we write 5 as the exponent. Same idea, x squared. We have x times x times x to the 5th, so multiply 5 more x's. So our base is x, since that's what we rewrote, and we rewrote it 7 times. X to the 7th power. Now here, this looks a little bit different for number 4 here. On the inside of the parentheses, number of parentheses always comes first there, 5 to the 3rd power. Okay, so that means 5 times 5 times 5. And this 2 on the outside is telling us we're going to write 5 times 5 times 5 twice. So here's once. Here would be twice. Right, and it's all multiplication here. Parentheses or just the dot is multiplication. Our base is 5, and we wrote that 6 times, so 5 to the 6th power. Number 5, same idea with -6 to the 2nd power, so that means we're going to write -6 twice. We multiply it twice, and we're going to do that 4 times because of that 4 that's all the way on the outside of those parentheses. Right, so I'm going to do that again. So -6 times -6. There's 2 times. -6 times -6. There's 3 times. -6 times -6. There's 4 times. And again, this is all just multiplication with our base of -6. And our exponent would be how many times we wrote this. 1, 2, 3, 4, 5, 6, 7, 8. So -6, which is in parentheses, raised to the 8th power. 6, a to the 3rd raised to the 4th power. So we write a to the 3rd first. So that's a times a times a. But we have to write that thing 4 times. A times a times a. There's twice. A times a times a. There's 3 times a. There's 4 times. So our base is a. And we wrote this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 times a to the 12th. All right, so here, 2 times 6. Okay, so it's telling us to write 2 times 6 3 different times. So there's twice. There's 3 times. I wrote whatever was in the parentheses, which was 2 times 6. So we have 2 different bases here. We have 2's, and there are 3 of them. And we have 6's, and there are 3 of them as well. So we have 2 to the 3rd power, 6 to the 3rd power. All right, 8x to the 4th. So whatever's in the parentheses, 8x, and we're going to write that 4 times. And again, we have 2 different bases here. We have an 8 and a
Students, you should now be going to your 5th hour class. Once again, students, you should now be going to your 5th hour class.
And if you count how many 8's there are 4 of them. That's how I got the exponent. And for the x's, there are 4 of them as well. So 8 to the 4th power, x to the 4th power. And our last one, AB squared. Okay, so we have A times B times B. So remember, it's B squared, so we're going to write that on expanded form as B times B. And that's 1 time. We need to write that whole thing in parentheses 4 times. So we have a base of A, switch colors, and I have 1, 2, 3, 4 of them, so A to the 4th. For the B's, I have 1, 2, 3, 4, 5, 6, 7, 8. So B to the 8. The last part of this MLO is combining like terms. So when adding two numbers with the same base and same exponent, we add or subtract the coefficients. So our first example is x to the 8th plus x to the 8th. So remember, our base is x and x. We have, in fact, the same base here. And our exponents are 8 and 8. So we have the same exponent. So what we do is we add or subtract the coefficients. And in front here of the variables are the coefficients. And since there is nothing written, remember those are both 1s. So 1x to the 8th plus 1x to the 8th. So we add those coefficients. So 1 plus 1 is 2. Keep the same base and same exponent. 2x to the 8th. Okay, so the variable or the base and the exponent do not change. And you keep x to the 8th. Example number 2. So we have the same base, x and x, and we also have the same exponent, 4 and 4. So we can go ahead and it looks like we're going to subtract this time the coefficients. Excuse me. So we're taking 5 minus 2, which is 3. And you rewrite the same base and same exponent, 3x to the 4th. Example 3.
Students, you should now be sitting in your 5th hour class. Once again, you should now be sitting in your 5th hour class. Thank you.
We have x to the 6th and x to the 6th. So again, it's going to be x to the 6th as our base. And we're going to need to add our exponent here. So 2 plus 5 is 7. So final answer, 7x to the 6th. Last example 4. So it looks like I have an x squared term. I don't have any other x squared terms. So this term is just going to stay as 3x squared. But then if I look at this, we have an x term and an x term. Now the exponents on those are both 1. There was nothing written as exponent of 1. So x to the first, x to the first. So then we can go ahead and add their coefficients. So 4 plus 5. So it'll be plus 9x to the first. And we don't usually write the first power, it's just plus 9x.